So this is mock paper 6 set 2. The question is about the separating mixtures. The apparatus in figure 1.1 can be used to separate the mixture of a liquid at different boiling points. What we call this technique? Name the separation technique that is used in the apparatus shown. So when we separate the two or more substances on the
Distillation.
basis fractional distillation. Look, if it was a simple distillation, then these beads will not be there. This is the main difference identification. You can identify that it's not a simple distillation, it's a fractional distillation. So beads will not be there. As the beads are there, it means this is a fractional distillation. On the basis of the boiling point, we separate the substances from each other. The next we have name the item of apparatus label A and B, what we call A and B. B is a beaker. What about A is a condenser? And draw an arrow on a figure where the apparatus should be heated, where we should supply heat energy. So it should be heated. The arrow should be at the base of a flask, round bottom flask. The next is figure 1.2 shows an apparatus that can be used to separate insoluble calcium carbonate from aqueous sodium chloride. State the term used for a solid removed from a liquid using this apparatus shown in figure. What we call the solid which is left here on the filter paper. So yes, we call that as a residue. And what passes through is known as the filtrate. Next is calcium carbonate obtained using an apparatus is contaminated with aqueous sodium chloride, means it has some sodium chloride. Describe how sodium chloride could be removed. Um, Actually, what it should be done, we should wash the crystal again, not dry. How we can look? Let's say this blue is representing the calcium carbonate, okay, CaCO3, and it is contaminated with some sodium chloride. Sodium chloride is a water soluble. So how I should remove this? So what I should do, I should wash with the distilled water. When I wash with the distilled water will dissolve the sodium chloride and it will pass through. So what I should do, pour a water over it. That is right. Pour a water, wash with the distilled water, use a distilled water. These are right. Drying will not make difference because why drying? The drying will not make much difference on that. Still, the trace is there. So whenever you want to remove because the thing is that you don't, like example, what might happen? This is aqueous sodium chloride, okay? Aqueous sodium chloride means water is there and that water is having a dissolved sodium chloride. Let's say this is representing the sodium chloride. The red dots are representing sodium chloride molecule. So when you're drying with the filter paper, so what it will do, it will remove the water. But the sodium chloride crystals, like sodium chloride ions, still remain there. So the best way is to wash. Okay. So whenever you want to remove the soluble impurities, you should always wash. The next is name a method of a separation that can be used to obtain a solid sodium chloride from aqueous. So we should use a crystallization or evaporation. Decanting will also not make a difference here. Decanting is when we pour the liquid out into another container and allow the solid to left behind. So if you want to separate a liquid from insoluble substance, that is decanting. So use crystallization or evaporation, both are acceptable, but not decanting. Decanting will not work. It's only for insoluble substances. Evaporation is acceptable. I said decanting is not. For two, no, if, in this case, why as you can read the question, they mentioned describe how sodium chloride, this is a sodium chloride crystals are there. Sodium chloride solution is there. Like you have a calcium carbonate, and the calcium carbonate contain aqueous sodium chloride. Aqueous sodium chloride means like water droplets which contain a salt. So if you are doing evaporation, you remove the water, so the crystals are sodium chloride crystals will be left behind. That's why you cannot say evaporation. Because as you supply the heat energy, the water will evaporate and the sodium chloride crystals will form, and there will be a crystal of sodium chloride and the calcium carbonate. So it's not separated. If I want to separate a soluble substance from the insoluble substance, then what I should do? I should add water. Because when I add more water, this water will dissolve all, like take all of this and move out. The second question, the student investigate the temperature change when a solid citric acid is reacted with sodium carbonate. A student does six experiment. For what he did, he placed 5 grams of a solid calcium carbonate in a 100 cm cube beaker. So there's a 100 cm cube beaker, and he put a 5 grams of sodium carbonate. Use a thermometer to stir the solid sodium carbonate for 30 seconds and measure a temperature. So he stir with a thermometer and he measured its temperature. In experiment 2, he added 1 gram of a citric acid to solid sodium carbonate. So he add 1 gram, like see both are, and use a thermometer and he stirred for 30 seconds and measure a temperature. Then he rinsed the beaker and thermometer with the water. Then he placed a 5 grams of sodium carbonate in a 100 cm cube and 2 gram of citric acid. Then he did experiment 6 times. 4 gram, 5 gram, 6 gram. And this is a table for us. So use the information, complete the table. So mass of a sodium carbonate, how much mass of a sodium carbonate he used? So the first temperature, so he used for all the experiment 5. Mass of a citric acid, 2 was there, 4 was there, uh, 4 or 3. Let me just check. It was the first experiment. 1 is there, then 2 is there, then 4, 5, 6. 1, 2, 4, 5, 6 is there. And these are the temperature changes. So you have to complete accordingly. Okay, just a minute. I will, because the graph is for temperature change in the mass of a citric acid. So mass of a citric acid was 2. I will write it here because I need these values to plot the graph. So 0, then 1, then 2, then 4, 5, 6. No 3 was there. 0, 1, 2, 4, 5, 6. 0, 1, 2, 4, 5, 6. And then the temperatures, uh, it was 25. Then it is 11.5. Then 0.5, -1, and -2. Okay. Now we have temperature scale first. Temperature scale is there. Complete a suitable scale on the y-axis. Look up what is our maximum value. Our maximum value is 25. And what is our minimum value? Our minimum value is 2. So our graph should have a variation, like maximum we should reach 25. So what should be the suitable scale I should select? 10, 20, 30, and then minus 10 will be there. Good. Then plot the results. It's 10 boxes equals to 10, so each is representing 1. So when it is 0, it was 25. So somewhat here. 1, 2, 3, 4, 5. Then it is 11.5. Should be in between because this is this is making 12. So it should be 11.5, means somewhat here. Then 2 and 5. 1, 2, 3, 4. This is 5. Yeah. Then we have 4 and point 0.5. Then we have 5 and minus 1. Below that. And then we have minus 2. Okay. Then we have to draw a line of a best fit. So look, line of a best fit, remember, as it through your points. So we have to, yeah, it will be a curve. So what we have to do, we have to join these points. A freehand graph we have to make. Sometime in the graph, one of the point appeared to be anomalous. So you ignore that. Like let's say one of the value was here. Example. So we'll ignore that. It is not lying on the line pattern. So we have to join them, the points. That is a line of a best fit through the points. This is line of a best fit through the points. So it's just a best fit curve you will draw. Because this statement give you an idea. It's draw a line of a best fit through your points. So you have to join your points. No, you don't have to do like this. The question is, some student got confused. Like in the question, if you see those points were there, and what they said, draw a line of a best fit through your points. So through your points means you have to join your points. You don't have to do like this, that the 3 points are above and 2 points are below. You don't have to do like this. No, that is wrong. Because in the question, line of a best fit is there, and that is through your point. So you have to join all these points. Okay. Is it clear, Ayan? So read the question. It's everything is there in the question itself. It is listed. What you mentioned, for example, in our mock, they said draw a line of a best fit only. It was only looking like a curve. 80% of the boys drew a straight line, but the marking scheme said it's a curve, so I got the right. Problem is, in physics, we drew a straight line, but in chemistry, do we have to look at a correlation or trend of point? Look, usually in physics, yeah, usually in physics, when they mention, your question is like example, let's say draw a line of a best fit. They don't mention that. And in that case, usually how you know whether it should be a curve in physics, because the quantities have a linear relation, so you draw a line of a best fit, the number of the points above and below should cancel out each other. That's right. But in chemistry, And how you will know whether you have to draw a straight line? You can read the last point. You can read the last point, like example, the point, usually if there's a straight line, they mention that find a gradient. So if you are confused that whether you have to draw a curve or a straight line, just in physics, you just read the next point, you will understand that what you have. If it's a straight line, definitely they ask the gradient for a straight line. So in chemistry, usually plotting is point to point. In chemistry, no. In chemistry, usually not the line of a best fit. You just join point through point. No need to bother. It will be a straight line or a curve. Chemistry is joining the points, just and excluding the anomalous results. Next is state whether a reaction between a sodium carbonate and a citric acid is exo or endo, and explain your answer. So, what kind of reaction is this? So, it's an endothermic reaction because the temperature of the surrounding decreases. Like not temperature loss, that's not the right term used. Temperature decreases. You can, but don't say temperature loss to surrounding, which is not at all a right term. So what kind of reaction is this? It's an endothermic reaction, and the simple answer, because the temperature decrease. If you have a mixture, if you have a mixture, let's say it started at 25, even it's a mixture of solid or a liquid, and final temperature is 22, so you will say this is an endothermic reaction because the temperature decrease. If you are starting at 25 and your final temperature is higher than 25, let's say it is 26 or 27, then it will be an exothermic reaction. No need to say surrounding at all. Like, no need to use the term surrounding. You just take the temperature of the mixture. If you find the temperature of the mixture increase, exo. Temperature decrease, endo. So answer here, it is an 1 mark is for mentioning like full answer. Endothermic, and reason is that because the temperature decreases. Don't need to use the term surrounding. And how we identify the temperature is decreasing, as you can read the table. In the table, they specify. In the table, they specify this as when we were mixing them, as we were mixing them, initially the temperature was around 25. Then the temperature is 11.5. Then the temperature is 5. Then the temperature is 0.5. So you can see the temperature is decreasing. If the temperature of a mixture is decreasing, it's an endothermic reaction. So endothermic reaction, temperature decrease; exothermic reaction, temperature increases. Deduce which experiment has a greatest temperature change compared to that of experiment 1. So when you're comparing a temperature changes, yeah, that's right. It changes from 25 to -2 because all the experiment, the starting was 25 and it has decreased to -2. Yeah, greatest change is there, greater maximum difference is there. From your graph, deduce the temperature after stirring obtained when 3.5 gram of a citric acid was added to 5 gram of a sodium carbonate. So you have to use your graph there, like how to use your graph. Like this was your graph, the mass of a, let's say this was a graph. So what we will do, We'll draw a line from 3.5 and identify what is the temperature change according to the graph. When 3.5 gram of a citric acid is added, what is the temperature change? Accordingly, we will write. So 1 is there, so we'll write 1. Next is suggest why solid sodium carbonate and citric acid are stirred before the temperature is measured. Why we stir them? Two solids were there and we stir them. Temperature temperature spread evenly, okay, so that all reactants react and increasing temperature. So the distribution, like yes, you can mention it's to mix them together or so they react and we have an even temperature throughout the mixture. So main reason is that we just mix them so that so we have an even temperature or same temperature throughout the mixture. Explain why using a polystyrene cup in place of a glass would increase the because polystyrene is a good insulator, does not allow the heat to transfer. They are better insulator or a good insulator. So it will prevent the heat loss or heat gain from the surround. Heat loss or heat gain, heat transfer. So whenever heat experiments are done, like at experiment which are done in which heat temperature increase or decrease, so we always prefer the use of polystyrene cup. Okay. So we prefer the use of if a like substance is heating up internally or absorbing heat. The next, a student test the two solids G and H. Just I'll zoom out so we can discuss this whole. So solid G, a flame test is done and it's give a lilac flame. So what this give an indication? If it's a lilac, it's a potassium ion. Heat half of the solid G in a boiling tube. Hold anhydrous. This is a test to check the presence of a hydrated compound, a cobalt chloride. So it means the water crystallization is present or hydrated compound. This is a hydrated compound. Dissolve the remaining solid G in a water. When we add sodium hydroxide, we observe a white PPT. So sodium hydroxide, a white precipitate. So what is sodium hydroxide and a white PPT? Adding a sodium hydroxide and a white PPT is aluminium or zinc as well because soluble in excess as well. So it might be aluminium or it might be zinc. So this give an idea, the possibilities it's showing that yeah, aluminium or zinc. To the second portion, we add acidified potassium manganate, pale purple solution is there. Sodium hydrox, when acidified, no sulfite, IT. To the third portion, yeah, SO3. To the third portion, we add a nitric acid followed by barium nitrate. This is a test for sulfate. So sulfate is present. So this give an idea that there's a potassium is there, maybe aluminium or zinc and hydrated and sulfur it's also there. What conclusion you draw about observation? It's a hydrated salt. If you say has water, but don't, it's not add another term has water of crystallization. Okay. State the conclusion can be made by about G. From test 4, what we can indicate? We indicate there is no sulfide present. Yes, you got the mark, I know, but the thing is, I'm saying a better answer. I'm not saying water is wrong. I'm saying a better answer is say it has a water of crystallization or it's a hydrated salt. They do award a mark when you write it has water. The next is the observation of a test 3 shows that one of the two possible cation in solid G, so aluminium plus 3 and zinc plus 2 plus, or identify the two ions those give must be present in solid, so sulfate and potassium. So sulfate identify two ions other than those given C, which must be there. So sulfate and a potassium should be there.